Thermoforming is a relatively simple, low-force, and low-cost manufacturing principle. In thermoforming, a thermoplastic sheet or foil is heated, then formed over a mold using a pressure difference, then finally cooled and cut to create a thin outer shell of the mold used. Thermoforming is a relatively recent process, with the first instance of use being acknowledged as the transparent acrylic domes on World War II aircraft. Today, thermoforming is used to create a number of products, such as automotive interior and exterior plastics, aviation paneling and interior components, enclosures for electronics like computers, printers, and MRI machines, exercise equipment, bins and storage solutions, hard shell suitcases, and blister packaging. Thermoforming has a much lower investment cost compared to similar manufacturing methods. It can produce a variety of shapes and sizes in thicknesses from 250 microns to 8 millimeters thick. Production tooling can cost 20% of a similarly sized injection mold. The turnaround time from design concept to prototype tooling and first part of the tool can be as little as 1 week, with aluminum tooling on the first part taking around 4 weeks. It offers a large range of texturing and finishing options. There are also multiple types of thermoforming: pressure forming and vacuum forming. Pressure forming is done by compressing air over a sheet onto a mold, creating a three-dimensional part shape. Vacuum forming involves using a vacuum to pull the material onto the surface of the mold. Each method has their own advantages and disadvantages. Our team decided to vacuum form for this project. The first step of the thermoforming process was to build a frame that would clamp the softened plastic to the vacuum box. The dimensions of this wooden frame were 15¼ by 12¼ by 3¼ inches. The goal of this frame was to create a tight seal between the plastic sheet and the vacuum box in order to maximize the pressure gradient and force exerted on the plastic. This ensures the tightest fit to the part being thermoformed, providing a more accurate and detailed mold. The second step of this process was to build a vacuum box that would hold the part being thermoformed. The vacuum box is composed of a top panel that holds the mold, with a number of holes drilled into it to allow the air between the plastic sheet and top panel to be removed. Underneath this top panel, there's a sealed chamber with a port to connect the vacuum. This box was built using the same dimensions as the top frame, allowing the tightest possible connection between the frame and the box. The third step of our process was heating the thermoplastic sheet in a grill with a temperature of roughly 390 degrees. The material selected was an 8x11 sheet of clear polycarbonate plastic. The thickness of this sheet is slightly less than 1/10 of an inch. The sheet was selected because it is inexpensive and readily available at most hardware stores. The working temperature of this material is 297 degrees Fahrenheit, one that the plastic sheet could easily be heated to by our team. Using a visual inspection, the team determined that the plastic was heated to the ideal temperature, then removed from the grill, and the frame was placed above the vacuum box and mold. Our team expected the thickness of the plastic to be a good balance between thin, preventing cooling issues, but thick enough to prevent yielding. However, the sheet size proved to be effective at deformation, but too thick to deform with efficiency. The mold our team selected for this project was a spool of string trimmer line. This mold was selected because it allowed air to flow through the string and create a tighter form against the spool. This gives for a great visual representation of the final thermoformed product. The final step to thermoforming this spool was to create the vacuum and mold our thermoplastic sheet. Using the vacuum attached to the bottom of the box, the suction removed the air, pulling the heated plastic down and over the mold. Once the plastic was cooled off, it was cleanly removed from the mold, creating a finished product. During this process, the team learned a number of valuable lessons. The frame which clamps the sheet to the vacuum box needs to be attached and heated together. This was not possible for our team using a wooden frame and our heating method. The plastic sheet we selected was effective at deformation, but was too thick to deform with efficiency. The plastic sheet slipped off of the clamping frames when the vacuum was applied. This also prevented full deformation of the product. Due to the colder outside temperature, the sheet cooled more than expected when it was being transferred to the thermoforming apparatus. This also reduced effectiveness of forming. Thermoforming has been an essential manufacturing process for many years now. It really has molded the world we live in.